Section 2.4, Complex Numbers. Expressing square roots of negative numbers as multiples of I. We know how to find the square root of any positive real number. In a similar way, we can find the square root of any negative number. The difference is that the root is not real. If the value in the radicand is negative, the root is said to be an imaginary number. The imaginary number I is defined as the square root of negative I. The square root of negative I is equal to I. If I pull that up in a calculator, let's see what happens. So if I put in the square root of negative 1, I get an error saying that it's a non-real number. So, using properties of radicals, well, what happens here? If I take I squared, meaning that if I square the square root of negative 1 squared, it's going to give me negative 1 because it removes the radicand. Now we can write the square root of any negative number as a multiple of I. Consider the square root of negative 49. We have the square root of negative 49. We can factor square root of negative 1. So we can write this now as 49 times negative 1. And then rewrite this as the square root of 49 times the square root of negative 1. What do you have to square to get 49 is 7. The square root of negative 1 is I. We use 7I and not negative 7I because the principal root of 49 is the positive root. A complex number is the sum of a real number and an imaginary number. A complex number is expressed in standard form when written as A plus BI, where A is the real part and B is the imaginary part. So for example, 5 plus 2I is a complex number. So too is 3 plus 4I times the square root of 3. So if we take a look at 5 plus 2I, the real part is the number 5. The imaginary part is 2I. Now, imaginary numbers differ from real numbers in that a squared imaginary number produces a negative real number. So recall that when a positive real number is squared, the result is a positive real number, and when a negative real number is squared, the result is also a positive real number. Complex numbers consist of real and imaginary numbers. Imaginary numbers and complex numbers. A complex number is a number of the form A plus BI, where A is the real part of the complex number, B is the imaginary part of the complex number. Now, if B is equal to 0, then A plus BI is a real number. If A is equal to 0 and B is not equal to 0, then the complex number is called a pure imaginary number. An imaginary number is an even root of a negative number. Now, if we're given an imaginary number, we want to express it in the standard form of a complex number. We're going to first write square root of negative A as the square root of A times the square root of negative 1. And then we're going to express the square root of negative 1 as the letter I. And then we're going to write the square root of A times I in its simplest form. So example 1, we're expressing an imaginary number in standard form. We're going to express the square root of negative 9 in standard form. So if we have the square root of 9, we can then rewrite this in factored form. We can write the square root of 9 and then factor out the square root of negative 1, and this is still multiplication. The square root of 9 is 3. The square root of negative 1 is I, so this just becomes 3I. So this is one term, 3I. Now, if we wanted to write this in standard form, this would be 0 plus 3I. Because there isn't a real part, we would then say that 0 is the real part and 3I is the imaginary part.